Hey everyone, this is Sahil back with another video. So this video is not part of the series that I'm doing. The project is same, which is bank using Solidity on Ethereum, but this video is quick overview video of the whole track, and this is kind of a proof for you know pro- proof for showing that I have done the whole track. And if you are not in the Discord server of Questbook, you probably won't get to see this video. So yeah, without further ado, let's get started with the code. I will give the overview of the whole code, and yeah, let's get started. So I've gone ahead and deployed the smart bank so that we don't have to wait. So here's the deployed smart bank. Let's get started with analyzing the code. uh, we can start from the top, or maybe we can start directly from the functions itself. Let me briefly go through the interfaces. So yeah, we have an interface for the compound and the functions that we will be using in our smart contract. We'll be using mint, redeem underlying, exchange rate sorted, and balance off. So I think most of you might not have seen this function, might not even have used a redeem underlying function. So what this function does is it takes the amount in ETH and it redeems that much equivalent amount of CETH tokens. So in case of redeem, we have to pass the CETH, but in case of redeem underlying, we'll have to pass the ether amount. Okay, so we'll use this function in the withdraw, but we'll see later on. And we have interface for ERC20 token. All right, and which we'll use to talk with the ERC20 token that will be either withdrawing from or depositing to. Okay, and for the Uniswap router as well, we'll be using three functions. One, swap exit tokens for ETH, swap exit ETH for tokens, and get amounts in. I will explain, and we have this weth function as well. I will explain these functions in detail later on when we come across them. So let's get started with the functionality head on. Okay, first we'll see the add balance function, and this will be without any ERC20 functionality, so we'll be adding directly the ether. So let's add the ether. So I've already connected or deployed the contract, as I already told you. Okay, I have some amount of test ether, 26.86 ether. So let's try to add one ether into a bank account. I'm adding the ether using this account. Okay, yeah, I've selected one as the value and ether. Let's click on add balance. All right, let's wait for the confirmation. Okay, while we wait, let me copy the address and paste it in this boxes for later use. Let me paste it over here, and here as well as here, although we won't be testing this. Okay, so the transaction went through successfully. So first we'll see if the balance has been added or not. So yeah, let me first go through the code, then I will test it up. Okay, so the add balance, when we call add balance, what it does is it calls this internal function mint, and we pass the value of the ether that we pass to this function. This function is payable, so that's why we were able to pass the ether. Okay, so let's check the mint function. Where is it? Okay, here it is. We get the amount of ETH and it's an internal function, right? We don't allow external contracts to interact with this. Okay. And yeah, it is internal, so the contracts that will inherit this contract will be able to call mint, but outside contracts which don't inherit this contract won't be able to call. Okay, that's what internal function means. All right, and so first we get the balance of our bank account. I mean, the balance of this bank account from the compound using this function called. So we get this ceth variable. First, let me show you what ceth is. So it's basically, I showed you the ceth interface, right? So we have the interface, but now we get the instance of that interface and we pass the compound ceth address, which is this one. It's the address of the compound contract that is deployed on the testnet, Roopstan testnet. That's what we are using. Okay, and we get the instance of that contract so that we can interact with it. Okay, let's go back to mint function. Yeah, so we call balance of, we pass the address of this contract. So this we can get the address of this contract using this this, and we get the amount of ceth of the contract. Okay, this is before we mint, right? Okay, and after that we call ceth.mint and we pass that the amount of eth that we got. Okay, so we got we came to this mint function from this call, right? So this is the message dot value will be amount of eth, right? And that's what we'll pass as value to mint as well, right? So what this will do is it will call the compound with this amount of eth, and it will deposit this amount of eth into our compounds account of this if of this contract, which is basically our smart bank or just bank, and we will get that much amount of tokens in our balance. Okay, when we mint this. So after that, we'll call the balance of function again to get the new updated amount of seed tokens. So this is the amount of tokens that we had before minting, and we get the new tokens after minting. So the logic is that after we mint, the tokens get increased, right? That's what should happen. So we get that, and using these two variables, contract after minting and ceth of contract before minting, we can get the ceth of that particular user who called this function. Okay, and we get that ceth of user. So after we have got the ceth of that particular user, we'll add that amount of ceth in the total contract balance. So we'll increment the total contract balance, and after that we'll add that amount to this balances mapping for that particular address which is stored in the message.sender, right? So and here we are incrementing the balances. That means I have already inculcated or integrated the functionality of depositing in paths, basically, right? So that you can deposit 1 ether after you have called this mint or add balance afterwards as well. You can call it as many times as you like. Okay, and that will add that amount of ceth to your balance. And yeah, so now that I have explained this c mint function, let's go back to, okay, there's nothing else after this c mint call. Okay, So that's it for mint call. So let's see if we got the balance in our account or not. So as we have already copied the address into this boxes, let's get the balance. So let's see what this get balance function will return. Where's the function? It's here. So let's first call it. Okay, we got this much amount. So what this will do is it will get the CETH that we stored in the balances mapping, and it will multiply it by exchange rate stored and divide it by 10 raised to 18. Okay, so this will basically give us the amount of ETH for that much amount of CETH. Okay, and this exchange rate shorted stored, we are fetching from the compound itself, and it will keep increasing, steadily. And we have to divide it by 10 raised to 18 so as to account, because it is shifted. And you might observe that this amount is little less than 1 ether. So let's count it up. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 and 18, right? So 9999 point something. So you can see some amount of way is not present. So I think that's the counted from I think that much amount of ether has been deducted from one ether by compound, I guess, but that doesn't matter. Okay, let's call the get seed func balance as well. So it will just give us the balance mapping value for that user. Okay, so we have 48 seed. So seed is has 8 decimals, so that's why this value is small. Okay, right, so we have deposited amount. What else can we do? We can call this function. So this functions are just for testing purposes, and I don't think I stored anything in them while calling mint. Yeah, I have commented it out. No, not this one. Yeah, we haven't stored anything, so they will be 0. Yeah, right. Okay, so now that we have added the balance, let's try to withdraw amount. Okay, so for withdrawing, I have coded 2 functions, withdraw max and withdraw, in which you can pass the amount of ETH to withdraw. So first we'll try to withdraw the max amount. So it will withdraw all the amount that is possible for that user, right? Withdraw max, where's withdraw max? Yeah, it's here. So first I think we should let's try to call it first. Withdraw max. Okay, let's check the value. Right now it is 25.86. So we should have at least 26 point something after this transaction is successful. Yeah, as you can see, the transaction was successful, and now the new balance value is 26 point something, right? And let's check the balance of that user again. So now it will be 0 because we basically withdraw the whole amount. And now let's analyze the function. So what we are doing here is first we get the address of that particular user who's calling. From message.sender, we convert that address into payable so that we can transfer money later on. And after that, what we'll do is get the balance of that user from balances array. So this will be the CETH amount. We'll call the CETH.redeem. So it will redeem the whole amount, whatever CETH amount that particular address has. Okay, it will redeem the whole amount, and after that we'll call. So what this C redeem will do, it will get that much amount of ether into our contract. So the value or the ether has not been transferred to the user yet, right? So it sits in our contract's balance. So now to transfer it back to user, what we'll do first is get the balance of that user. So we have not decremented the value of that user's balances. So first we'll get the balance by calling get balance. So what this get balance will do is it will take that user's address and get the balances that we have not yet zeroed out, multiply by C, that exchange rate, and it will give us back the amount of ETH that should be redeemed to that user's account, right? And we get the amount of ETH in amount to transfer, and after that we will uh, uh, reflect the contract's balance by decrementing that much amount of seed, right? So because we have already redeemed that amount from compound, we'll decrement that amount, and after that we'll zero out the that user's balances because that user withdraw the whole amount. And after that we'll call the transfer function on this transfer to variable, and we'll pass the amount to transfer which we got from get balance. So this will transfer that amount back to that user which we already got, right? Yeah, so that's it for the withdraw max function. Yeah, and now we'll see withdraw ERC20, right? Yeah, first we'll have to add the balance in ERC20. So for that, let's first head over to DAI tokens contract. Yeah, this one I think. We'll try to add DAI balance to contract, right? So let me copy this address, and first to add the balance, yeah, let's see. I think I should first tell you how it will work, then we'll try to add the balance, then we'll analyze the code. Okay, so for that function to work, first we'll have to approve our contract that much amount of DAI, right? So let's head over to contract, and first we'll try to write contract, connect to web3. Okay, so first we'll call the approve function. So let me first copy the address of this smart contract, which is this one. I copied the address of the smart contract. I will pass it in the spender's address. Okay, and I will pass, let's say 10, and DAI has 18 decimals, so we'll have to convert this into 10 raised to 18. Okay, so now before calling this function, let's see what this is going to do. So right now I'm connected to this contract using my MetaMask account, and I will be calling this function with this edit with this account, which has, I think I have some DAI. Yeah, I have 863 DAI tokens. And what I'm doing by calling this approve function is I will approve this spender, which is this balance, this smart contract or bank. I will approve that bank to spend my 10 DAI tokens, right? So it will be spending that much amount of DAI on behalf of ourselves. Okay, so let's call this right. Confirm. Let's wait for the confirmation. Okay, it might take a while. Okay, it has been approved, but we didn't get the notification here. That's strange. So let's copy this address, contracts address, and now we'll head over to our contract, and let's see. Let's first try to get the allowance, right? Let's paste that address. So what this function will do is, let me show you. Is that food allowance, get allowance? Yeah, it's here. So it will take the ERC20 token of addresses token's address. So in our case, it will be DICE address, and it will. So I showed you the interface for ERC20 earlier, right? So it will create an instance using that address, ERC20 token address, and now we can call that uh, to contract, right? So what we'll do is, after creating the instance, we'll call the allowance function, and we'll pass the message.sender. In this case, it will be whoever calls this get allowance. So right now, if we click this, it will be this account. It will be, the function will be called from this account A02, and that's the same account through which we approved the die, right? This account holds that die. So let me call this function get allowance, right? We got this number, and we will also pass this address dot is. This is the spender basically. So what we are saying by calling this function is, hey ERC20, get me the allowed amount for this owner, for this spender, and for this owner, right? So it will give us back the amount that this spender has approved to this this owner has approved to this spender, and the spender is, in our case, this bank, right? So we get the allowance, and it is this much, 10 DAI tokens. So now that we have got the allowance, what we'll do is we can, you know, use that much amount of DAI token. So let's copy this address of the DAI token. Now we can use this address to add the balance in ERC20 or DAI. Where is add balance here? Yeah, here. We need to pass the address, and yeah, let's first call this, and then I will explain what it does. Okay. Add, what just happened? Yeah, let me try to call it again. This happens sometime. Yeah, so see, it went through this time. And now let's see what this function does. Add balance ERC20. So when we pass the ERC20 token address, it will call this swap tokens for ETH function, and it will pass this address. So this function does basically what it says here. It swaps the token, this ERC20 tokens, for ETH, right? So let's go to this function, which is this one, swap tokens for ETH. We get the ERC20 token address, and after that we again call approved tokens to Uniswap. So see, let me explain the flow here. So now we have got the approval for that user's token, right? Now what we need to do here is we need to send those tokens to Uniswap, so that Uniswap can give us the equivalent amount of ETH, right? But to give it to the Uniswap, we'll have to approve this approved tokens. To We have to give the approval to Uniswap to spend this token, right? Before Uniswap contract can swap this token. So this is what this function will do: approve tokens to Uniswap. Let's go to this function. It will take the ERC20 token address, again get the instance, it will call the allowance and message.sender and address.this, right? We'll get the allowance, and after that so it will, what this call will fetch, I think I already explained you, it will get us the amount of ERC20 token that has been approved by the message.sender to this contract. We'll get that amount in this variable amount, approved amount, and after that we'll have to transfer that much ERC token from message.sender to this contract, right? Address.this. So we'll call this transfer form. It will transfer that much amount of ERC token into our account. And now that we have got that much amount of ERC20 token, now we can, call the approve function, and we can approve that much amount to Uniswap, so that Uniswap can again, transfer the token from this contract to its own contract and swap that token, right? So we'll call approve the token amount to Uniswap, and Uniswap router address, it's here. We're getting the address from Rupston. So this Uniswap router has been deployed to Rupston as well. We get that address and we call the approve, and we get the approve amount of ERC20 token, and we return it back. So let's go back. We get the approve amount of ERC20 token. So now see what has happened is we have transferred ERC20 token from message.sender to our contract, and now we have approved that much ERC20 tokens to Uniswap. So now Uniswap has the power to take those tokens back into their account, not back but into their account, right? So now after that we'll get amount ETH minimum. So this is basically, I'll explain you. Amount of ETH minimum is 0, 2 is equal to this address. I will explain what these variables are. Okay, let's just first read it. 2 is this address, contract's address. We get the deadline, so it will get the block.timestamp. So this block.timestamp will have the value of the time when this call will be executed on the blockchain, right? Not when we call this function, but when this call will get executed in that particular batch. I think I explained this concept in my first video, so check that out if you want to understand it. So let's get the deadline. We get the block.timestamp plus 24 into 60 into 60. So 24 for 24 hours. We convert it into minutes by multiplying by 60, and then again we convert it into seconds, right? So we get the seconds. So this block.timestamp gives us back the seconds. UTC, I think, yeah, that format doesn't matter, but we get the time in seconds at that particular moment, and we get the seconds after 1 day, which is 24 hours later. So that's the deadline. After 1 day is the deadline, right? It's just one variable that we have to pass to this function. We'll see later on, it doesn't matter. And path, so this path variable, we have an array. This path variable is an array, and for the first element we'll pass the tokens address, and for the second we'll first call Uniswap for getting W8. So what this will do is, it will give us back the, so see, here we got this DAI tokens address, right? So we needed this DAI tokens address to interact with it. But now what we need to do is swap the ERC20 tokens for ETH, right? So now to get those ETH, we have to get the wrapped ETH. Wrapped ETH is basically, ETH, but in terms of ERC20. So it is ERC20 compliant Ether, right? So that we can swap, or Uniswap can swap the ERC20 tokens for those ETH. So we pass it into second index, and yeah, so after that we'll get the we'll get the balance of this contract, right? So when we call this address, this dot balance, we get the ethers that are present in this contract, right? In the bank contract right now, and we store it in contract balance. I will explain why this is needed. And after that, what we'll do is we'll call Uniswap swap exit tokens for ETH function. So what first, let's see what we are passing. We are passing the token amount, right? The token that that user wants to withdraw, or that amount of token that the calling user has approved, right? And we pass it as first parameter, and for the second parameter we pass this amount ETH minimum is 0. So it's basically for saying or telling Uniswap that hey, we want at least this much amount of ETH, but we are passing 0 because we don't want this function to fail, and it doesn't matter, even if we don't get the maximum amount of ETH possible. We are just testing this, right? So we'll pass 0, and we'll pass this path array as well, which contains the addresses of the two pairs that we are going to swap. We are going to swap the ERC20 token. So in this case, we have swapped DAI for Ether. So that's why path 0 will be DAI tokens address, and path 1 will be Ether or wrapped Ether's address. And 2, right? So this 2 will be address of this contract. So we'll say to Uniswap that hey, swap those tokens for ETH and send those ETH back to this contract. And we pass the deadline that I showed you earlier, and this is basically, I think, for telling Uniswap that that's the deadline. I think we pass it so that we give this much amount of time frame to Uniswap for doing this transaction or something. I will have to check it out. But yeah, and ignore this for now. So I had one test variable here, that's why I'm calling. So let me just show you what this does. So this swap exit tokens for it returns an array. Let me show you the interface. Swap tokens for it returns an array amounts, right? And this amounts will have the amount that was swapped, and the token, I mean the amount of tokens, right? The pair that was swapped. But I found that when I get the amount of ether that was swapped, it was always 0. So it must be because of this amount out minimum. But yeah, it doesn't matter. Yeah, so after calling swap exit ETH, we'll again call address this dot balance, and this will give us the latest balance of this contract, and from that balance we will subtract contract ETH balance that we got before swapping, right? And we pass it into ETH after swap. So this accounting is just for checking how much ETH has been swapped, or how much ETH we got from by swapping that much ERC20 token, right? So this is the amount of ETH that was swapped, and we return that amount back to this function. We get it in this variable, and again we call mint. So see, this mint function is the same function that we showed earlier, right? This mint in add balance. So in case of add balance, simple add balance, we are calling mint directly because we had that ETH directly, which was paid by the user directly to this contract, right? Through this pay function, we had this value. But when we are adding the ERC20 token, what we have to do, I already explained the flow. We get the ERC20 token and we approve, we transfer those token to our contract, then we approve Uniswap to Uniswap that much amount, and then Uniswap will transfer that ERC20 token and it will swap that token for ETH and it will give us back the ETH, and that's what we got here. And after that we'll mint that ETH, and mint is basically saying that we'll send this ETH to Compound and we'll do the necessary accounting. I already showed you, right? And I think we already withdrawed it. Did we? Let's call this get balance. Yeah. So yeah, we did. We haven't withdrawed it yet. So this is the amount. This is the amount that we got after depositing this ERC20 token for that particular user, right? And the allowance should be 0 now because we swapped the token already. So this is the balance. This is the amount of ETH that we can get for the swapped tokens, and this is the CETH, right? So that's it. And now see, we have added the ERC20 token in our contract as well. Now we can do two things here. We can either withdraw in ETH, or we can even withdraw back. We can withdraw in ERC20 token. So I think I did not show you how to withdraw in parts, right? Let's just withdraw the whole amount in ETH first. So let's call withdraw max. So right now we have like 26.86 ether, right? So, and if we check the balance and if we check the DAI amount, as you can see, the DAI amount is 853 and earlier it was 863. So the DAI tokens were deducted, and now what we'll do is get that much amount of ether, the equivalent amount of ether or that much DAI token back in our contract by calling withdraw max. Let's call it. Okay, let's check. So it's right now something 36694 ether. It should increase after this call. Okay, so the balance has been withdrawn. Let's check. So as you can see, the amount has increased, and if we check the balance of that user, it will be 0, right? Because we withdraw the whole amount in ether. So what we did here basically is we deposited the amount in DAI and we withdraw that much amount of ether back into our account, right? Okay, so let's now try to call this withdraw function. Mm, let's now try to call this withdraw function with amount in parts. So first, let's first deposit 1 ether, then we'll try to withdraw the ether in parts. Let's call at balance, confirm. Okay, it has been confirmed and it was successful. Let's check the balance for sanity. Yeah, we have got this much amount of ether that we can withdraw back. And now let's try to withdraw in parts. Okay, so for that we'll call this function withdraw, and we have to pass the amount of ETH in way. Okay, so we can call directly this much, this much, but for that we already have this withdraw max function, right? So, and that won't be a test for withdrawing in parts. So let's withdraw some amount from this. So let me do the math here. So we'll withdraw only this much amount minus, let's say, 10,000 V. So we will we won't touch 10,000 V from the contract. We'll only withdraw the result of this amount. Let's get the result first. Okay, they should have given us the value in the way format. How can I get it back in way? You know what? Let's try to play around with this. See if it gives us back the exact value. I need the exact value. Let's pass 4999 or something. Nope, doesn't give us back. You know what? Let's just enter the way value directly. No, let's go to this side. ETH converter. Yeah, it's this one. Let's enter 0.5 ETH, and this is the way value. I should have done this earlier. Okay, let's head over to contract. Let's add where's the withdraw? Yeah, let's add amount. And before we do that, let me check the balance again. Okay, is it getting called or not? Yeah, it's getting called. CE, this is the amount of CE, get balance. All right, so let's try to withdraw 0.5 ether. Confirm. Okay, this value should increase if this is successful. Let's wait for it. It's taking a lot longer. Oh, okay. So withdrawal was successful. We got 0.5 ether. And now that we have withdrawn in parts, let's check the balance. Now this is the balance. You see the half of C ETH has been deducted and half of ether has been deducted. So this is the amount. Now, you know what we can do? Let's withdraw all of this amount now. So we'll call withdraw max. So this should withdraw the whole amount. Let's check. Hmm. 26.38. Okay, it should be around 26.80 or something, right? Yeah, so we have 26.88. And now if we check the balance, it's zero. See it balance should be also zero. Okay, that means our withdraw in parts function is also working. Okay, so I think I did not analyze the function. So now that we have tried to withdrawn in past, let's analyze the function. So before when calling withdrawn function, we pass the amount of ether to withdraw. Okay, that we saw already. And first we have this check in place, which is for checking if the amount of ether that the user is trying to withdraw is whether it is less than or equal to the balance that user has or not. You know, we don't want the user to withdraw the amount that they don't already have, right? So if the user tries to call the function using the amount that they don't already have, this will throw an error. You don't have enough bells. Okay, so that's the check right there. And if this check passes, then we get the message.sender, the address, and convert it into payable, store it into transfer to. After that, we will be calling withdraw ETH from compound, and we'll pass the amount of ETH to withdraw to this function. So let's see what this function does. Withdraw ETH from compound, and we are passing the amount of ETH to withdraw, right? Okay, where is it? Withdraw ETH from compound. Yeah, it's here. And we pass the amount of ETH to withdraw. And after that, what we do is first we get the balance, CETH balance of our contract, right? We store it into CETH of contract before withdraw. After that, we call this redeem underline function on CETH. Now I told you earlier about this function, redeem underline. So let's see what it does. So we have this amount of ETH to withdraw, right? We pass it into redeem underlying. So now what this function, so up till now we have been using only redeem function, right? And in the redeem function we pass the CETH, but now in this case we are passing amount of ETH to withdraw, right? So what this function will do is it will take this much amount of ETH. It will redeem the CETH that we have for this smart contract, and it will redeem the amount that is redeem the amount of CETH that is equivalent to amount of ETH, right? And after that it has redeemed that much amount, it will transfer back that much ETH to this contract, right? And after that what we'll do is again call CETH balance of. So see what we have done here is before calling redeem underline we are storing the value, uh, the amount of CETH our contract has, right? CETH of contract before withdraw and after withdraw, so that you can we can get the amount of CETH that has been withdrawn, right? For this much amount of ETH, and we get that in CETH withdrawn, and we return this variable back to our function withdraw right here, right? So what this function has done is it has it has taken the amount of ETH, it has withdrawn that much ETH from the compound, and it has deducted that much. I think we have not deducted it yet. Yeah, so it has deducted that much ETH or that much ETH from their own contract. I mean, compounds, the compounds contract. But now we have to do our own accounting, right? So for that, we get the CETH withdrawn, the amount of CETH that was withdrawn. And for our own accounting, what we do is we deduct that much amount from total contract balance, because that much CETH has been withdrawn. And also we deduct that much amount from balances. So see right here, in this case, uh, uh, we are just deducting that much CETH withdrawn, right? But in the withdraw max function, we were just setting the balances to 0 because we were trying to withdraw the whole amount, right? But in this case, we are not withdrawing the whole amount, we are withdrawing it in parts. So we'll be deducting that much amount of CETH only. And after we have done some basic accounting, finally we'll do the transfer. We'll pass the amount of ETH to withdraw. We'll call the transfer function on this transfer to, which is basically the payable address. It will transfer that much amount of ETH back into the user. So there you go. The flow is totally done, right? The amount of ETH has been withdrawn, and the user doesn't have to know that the amount has been withdrawn from compound, right? Because they only care about that ETH. Okay, that aside, so now that we have seen withdraw function, so let's review what we have reviewed till now. We have checked add balance, we have checked add balance ERC20, and we also, so these are internal function which are being called, so let's not take those into account. And withdraw max and withdraw as well, we have seen these. Okay, so now the only function, the only two functions remaining, that we no, I think we did not see ERC20. So two functions are remaining: withdraw in ERC20 max and withdraw in ERC20 the amount of token. So that's what we're going to see next. So let's first start with withdraw ERC20, but before that, we'll have to see for this to work. Swap ETH. So what this withdraw ERC20 will do is, whatever ERC20 token address we pass, we'll get the amount of ether that we own back into this, converted into ERC20 token that we passed, and we'll get that much amount of ERC20, right? Swap it for tokens. Okay, there you go. And now what we'll do is, yeah, first we'll add balance. So let's try to add balance in ether, and then we'll try to, so see, there are many test cases and different scenarios that can occur in this bank, but just for the sake of reviewing the code, I'm not gonna go into all the test cases. Maybe in the future I will create a test file, test script for testing all the use cases, but for now let's just skip other cases and let's review the usual cases. Yeah, so before we do that, let's check the balance first. It should be 0. Yeah, the balance of this. So if you're only interacting with this one account only, right? Just for the heck of it. Yeah, let's get to it. Let's add one ether back again at the balance. Okay, let's wait for it. All right, transaction was successful. Let's check get balance. What happened? Okay. They should return the value, isn't it? Did it not add the balance? It did. Oh yeah, we are getting it. I don't know why we were not getting it earlier. Thank God. Okay, let's see. Now that we have added one ETH, we'll try to withdraw in DAI. Okay, so let's get the DAI's address. We can use any ERC token for which the liquidity pool exists in Uniswap. But just for the heck of testing, we'll use DAI tokens. Okay, let's withdraw. So first we'll try to withdraw the whole amount. So where is it? Withdraw max. Let's pass the ERC20 token address. Let's call it. Okay, we should get back 1 ether worth of DAI tokens. Let's check. 853, and let's check again. Where is it? 1278, right? So we have got 1 ether worth of DAI token back into our account. So what we have done here is we have deposited ether worth of we have deposited 1 ether, and after that we have swapped that ether value and we have withdrawn one that much amount of DAI tokens. All right, and let's now get into the code of ERC20 max, withdraw ERC20 max. So let's see what happens when we call this function. We pass the ERC20 token address, okay, and we directly call redeem function. So what this will do, so in this case we are withdrawing the whole amount, right? The amount that that particular user has, the whole amount, and we'll get the amount of CE that particular user has through balances. Messenger sender will redeem that much amount of ETH. Okay, so now after calling this, our contract will have the amount of ETH that particular user can redeem, right? And after that we'll call this get balance. So what this will do is it will give us back the amount of ETH that we just withdrawn. So we are already seeing this function, right? We are just passing the, where is it, address. We are getting the balances and convert it into ETH into ETH, and we get it back. And we can do this because we have not yet zeroed out the balances of method.center. So once we get the amount of ETH that we redeemed for that user, after that we will do the accounting work. We'll subtract that much amount of ETH from total contract balance, and after that we'll zero out the balance of that user. And there comes this function, swap ETH for token. So see, when we call withdraw ERC20, the user is expecting the ERC20 tokens, right? So if we are calling with DAI tokens, then we expect to get the DAI tokens back, right? But right now we have only redeemed the ETH. So now we need to swap this ETH for the token that we want to receive, right? So for that, we'll call this function swap ETH for tokens. We'll pass the contract address. In our case, it is DAI when we call this function just earlier. And we'll pass the amount of ETH to swap. So let's check swap ETH for tokens. It's right here. We get the address, amount of ETH to swap, and this is what we saw earlier already. The only difference is path 0 now will be ETH and path 1 will be token. In earlier case, I think in deposit, yeah, I think in deposit, yeah, let's not get into it. In deposit, it was the reverse, the token was zeroth, the token was in the zeroth index and the ETH address was on the first index. But now what we want to do is we want to swap the ETH that we have for tokens. Earlier we were swapping the tokens that we had for the ETH, right? So whichever we have, so in this case we have ETH, so that should be the first element. Okay, and yeah, pass the amount of ETH to swap that we got from this parameter, and we call Uniswap. Uniswap will swap those ETH for tokens. And see, in this case again we'll get the amounts array back, right? And we can get the tokens that we got using this first what is it, first element. So swap exit ETH for tokens will return us the amounts array, and the first element will be the ETH that we swapped before, and second element will be the amount of token that we swapped. So we'll get those amount of token from first index and we'll store it into ERC20 token amount, and we'll send this token amount back to ERC20 token amount, right? And yeah, so you know what, the the thing is, in this case when we swap ETH for tokens, see what we are doing is, to this variable 2 we are directly passing the address of the sender. So we are basically telling Uniswap that, hey Uniswap, take this amount of ETH and transfer back the equivalent amount of tokens back to this address, and this address is in this case the user. So we are not even redeeming the amount of tokens in our contract. We're directly telling Uniswap to transfer those tokens back to the user, right? So we don't need to do any accounting afterwards. We don't need to transfer it back. So Uniswap will do its thing and that's it. So this is just for testing purpose. So you can ignore this mapping test 2. Yeah, so that was it for withdraw ERC20 max. And after that, we have this withdraw ERC20 but in parts. So let's now see how it works. Okay, so again we'll try to add one ether. Let's first check that the balance is 0, just for the heck of it. Okay, contract balance is 0 because we are the only user. All right, let's deposit one ether. Balance. Okay, so the transaction was successful. Let's check the balance of the user. Okay, we have got one ether minus some amount. Let's not worry about it. Now let's try to call withdraw in ERC20, right? It's this one. For that we'll need, so again we'll try to withdraw in DAI tokens, but this time we'll try to get the DAI tokens in parts. And let's see how much DAI we have. So we have 1278.738. Okay, so you know what I could have done? I should have also provided, a function such that the user can check that how much amount of a particular token they can retrieve given their account balance. So that suppose, let's say I come to this bank and let's say I want to check, I want to withdraw the amount in DAI, and I don't want to, I just want to check first that how much DAI I can get given the amount of ether that I have in the bank, right? And then once I've got the total amount I can get in DAIs, I can withdraw in parts using this function. But right now, as we don't have that function, we'll just try to guess how much ETH we can get. So let's do that. Okay. We'll have to call the withdraw ERC20. It's where is it? Yeah, here. And wait, I need to get rid of this quotes. All right. And now I need to pass the token amount. So let's now try to guess the token amount number, right? So let's see DAI tokens. Let's not try to guess. Let's just check how much DAI tokens we can get using Uniswap. We are already connected to Rupston, ETH, and DAI coins. So for 1 ETH, you can get this much amount of DAI. So we don't have exactly 1 ETH. We have something like 0.999 something. So let's just try to withdraw 400 DAI tokens, right? Okay. But before we do that, there's one thing. So 1 ether is this 400, because we need to pass this amount in way. So that's why I'm converting 400 into way. So it doesn't matter we are using the ether converter, because the DAI tokens are also in 18 decimals. So, and the ETH is also in 18, so it doesn't matter, both are equivalent. Okay, so let's copy this way and let's try to withdraw that much amount of way. Let's see if this works or not. Fingers crossed. Okay. Right, let's confirm it, and let's check the amount of DAI that we already have before we get 1278. So now it should increase. It should have like 1600 or something. Let's check. Yeah, we got the 1600 or the 400 worth DAI tokens. So that means withdraw ERC20 token 20 function works. Great. And now let's check the balance. So now we have only this much amount of ETH. Now what we can do is we can withdraw the whole amount, right? Oh, let's check how much is this. I mean, how much amount of ETH. So this is in way, so let's convert it into ETH. This is the amount of ETH, and if I paste it here, paste it here, 24. Yeah, so I have 24 DAI tokens already. So if I try to withdraw the whole amount, I should have 1678 plus 24 tokens. So let's do that. Withdraw the max. Where is withdraw? Yeah, withdraw max ERC20. Do I have? I do have. Oh, it's here. Okay, need to get rid of this quotes. I don't know how this gets into text box. Let's withdraw the whole amount. Let's transact, and after this transaction is done, we should have 24 DAI tokens. Okay, let's wait for the confirmation. Okay, let's refresh it. So right now it is 1678. Cool. We have got the whole amount. Now the balance should be 0. Well, it is. And now that we have done the flow, let's analyze withdraw ERC20 function, which we can use to withdraw in parts. ERC20 token in parts. So we pass the ERC20 token address and we pass the amount to withdraw in token, right? And we call get ETH amount for ERC20 token. So this function does what it says. It will no wait it won't do any swapping or anything like that. It will just get us the amount of ETH we can get for no I mean we have this amount to withdraw in tokens, right? So we will take that amount and we'll take that address. So let's say we are calling to get the DAI tokens. To withdraw the DAI tokens, we'll pass the DAI address and the amount of DAI tokens. Now we will call this get ETH amount for ERC token function to get the ether value for that much amount of DAI tokens. So let's say I pass 20 DAI tokens. So I need to get the value in ether for 20 DAI tokens. So for that, I will call this function get ETH amount for 20 ERC20 tokens. So let's see what this function does. We pass the address and the amount to withdraw. After that, we have this again, this path variable, path array, and we pass Uniswap WETH address as the first index, and the second is the 0th index, and the first index will be the token address. And now we'll call the Uniswap's get amounts in function. So now this is a new function. We have not used it until now. What this function will do is it will take the amount of withdrawing token, right? So this, let's say we're calling with 20 DAI tokens, so it will take 20 here, and we are passing the path, and the path has the WETH and the token address. So what basically this does is we are asking Uniswap to take these two addresses. The first one is the amount that we need, and second one is the amount that we are passing, and we are asking Uniswap to take the amount that we are passing and convert it into the amount that we want, and the amount that we want is being passed as the 0th index. So in this case we want, let me just simplify it. What we want is I think I already told you, we want a ETH amount for that much amount of tokens. So we use this get amounts in function of Uniswap. We pass the amount of tokens to withdraw and the two addresses, the two pair for which we want the amount, WETH and token address. And we will get an array, but we are concerned with only the first value, which will be the value of ETH that we want. So we store it in amount of ETH withdraw, and we'll return it back. Let's go back to it, withdraw function. We get the amount of ETH to withdraw now, right, for this much amount of token. So why do we need this variable? Because see, we have all of our money in the compound, right? And the compound holds the money in ETH, but now we want to withdraw the money in ERC20 token. So we want to first get, we want the amount of ETH that we should withdraw, or we have to withdraw first, right, for that amount of token. So that's why we call this function. We get the amount of ETH to withdraw, and first we check if the amount of ETH to withdraw is less than get balance message.sender. It's just for the check, so that our user don't don't try to get the amount of ETH that they only that they or they don't try to withdraw the amount of ERC token for the amount of ETH that they don't already have, right? So first we check that, and if it doesn't pass the test, we'll throw this error, you don't have enough balance. If it passes, let's go on. We'll call this withdraw ETH from compound. So now we have got the amount of ETH to withdraw, right, through this function. Now what we want to do is we want to withdraw that much amount of ETH from the compounds contract, so that we can take that ETH and swap that ETH for the tokens that the user wants. So we'll call this withdraw ETH from compound. We'll pass the amount of ETH to withdraw. Let's check this withdraw ETH from compound. I think we already saw this function. So that's the beauty of modularizing each and every code. We have used this function twice already, withdraw ETH from compound. It's a basic function that we use again and again. So we'll pass the amount of ETH to withdraw. We have gone through the whole drill, so we won't go into it again. Pass the amount of ETH, we get that much amount of ETH. That's what we are concerned with. Okay, see it withdrawn. We store it in see it withdrawn. So now we have got the see it from we have got the ETH from compound, right? That much ETH. But we want the ETH to do the accounting work. So we'll subtract that ETH from total contract balance and balances. That's basic thing. And after that, we'll again call this C. The user wants the money in tokens, ERC20 tokens. I mean, they want ERC20 tokens, right? They don't want ETH. But until now, we only have ETH. So we want to swap that ETH for the tokens. And for that, we pass the address of the token that we want and the amount of ETH for which we want the tokens. We call the swap ETH for tokens. I think we already saw this function and already used it. So yeah, let's not get into it. It will just return the token amount that we got back, right? So that's the ERC20 token amount, and that's it. And see, as we already saw, this function or Uniswap exec ETH for tokens, it will directly pass that much amount of or transfer that much amount of token to the user by passing the contract. So there you go, the flow is complete. Again, this is for testing, test 2, whatever. Okay, we have checked withdraw ERC20 as well, and I think it's done now. We have gone through the whole code. Or have we? By the way, you are seeing this amount because, as I told you, we use this test variable. I was just using it for testing, and after withdrawing, I am not doing anything to that variable because it was not the main code for the bank. It was just for debugging purposes. So I was just so this let's just check it. Withdraw ERC20 balance, right? So it will give us back what? It will give us back the test2 amount, test2, and what we have in test2, the amount of ERC token that we just withdrawn. So that's here, right here, 24 tokens. And if you remember, at last we tried to withdraw 24 DAI tokens. So that's the amount right here, 24 DAI in wave denominator, right? Okay, so that's it. I think for the bank code, we have gone through all the code, and I think I have coded all the functionality. We have the functionality to deposit and withdraw, and in that as well, we have the functionality of depositing in parts excuse me, we have the functionality of depositing in parts. We have the functionality of depositing in ERC20 tokens. We have the functionality of depositing ERC20 tokens in parts. No, we don't have it. We can do it, but that's not important because, yeah, I mean, we can do it in parts, right? But for that, we have to approve that much amount in parts. So let's say I want to first with deposit 20 DAI tokens. So I only approve 20 DAI tokens first through this contract. After that, I approve another amount. We can again make it much more sophisticated and give the user to not approve each time, but only transfer only a fraction of the approved token. We can do that, but that's it. Yeah. So yeah, we have a cool bank. We have a whole lot of functionalities, and that is it for the bank part. So this covers the whole lot of part: quest 1, quest 2, and quest 3 as well, right? Bank for all cryptocurrency. Yeah, so we have a bank for all cryptocurrency. We can uh, use or deposit or withdraw in any ERC20 token that we want, right? So there you go. And after that, we'll see the code or analyze the code for the fourth quest, which is somewhat not totally related to this quest, but at the end, we'll try to inject this with the bank code as well. So we'll try. So in the fourth quest, we'll try to launch our own coin, launch our own ERC22. So up till now, we were trying to only deposit and withdraw the ERC20 token that are already available, like DAI. But now we'll try to code our own ERC20 token, and we'll try to withdraw and deposit that token, right?